Okay, let's get back to doing some electrical mechanical stuff. Politics are fun, relevant, and you need to follow them. But channel name's electrical mechanical stuff. So what we have here is an MPP solar, all-in-one 6 kilowatt inverter, hybrid. So cover up my serial number. This is a inverter charger, hybrid LV6048, 48 volt. And I can charge up to 54 volts. So this is not a grid-tied inverter. It's a hybrid, meaning I can only pull from the grid. I cannot push into the grid. I've seen quite a few reviews on this thing, and they look promising. It essentially has two 3 kilowatt inverters that sync together to give me split phase 122/40. It has L1, L2, and neutral for the AC input, and ground, obviously. Same thing for the output. It's got a breaker for the input, breaker for the output. It doesn't say how many amps those breakers are rated for, but it should be 30. So we got dual 80 amp PV array, so 8,000 watts PV array. I'm getting a 7.2 kilowatt system. Here's where the DC comes in, and you can see back there in that bar, there's those wires that jump over and basically link to this one. So it's two independent 3 kilowatt inverters with a MPP solar charge controller right in the middle. You can parallel them up to 18 kilowatts. I believe I'm going to get a second one. I have 12 kilowatt because I got a lot of electrical loads, but we're going to see how it goes first. I've got all the screws out. Reason why I covered up my serial number, do it again, because that stupid sticker is covering up a screw hole, which I can only assume is the tamper sticker. So we can only kind of just peel it. Take a look in here. So essentially, this black box is one set of, and this is just like a plastic cover. There's videos of other people opening these things up. This is just a plastic cover for the airflow on the fans that are in here. Goes over a big heat sink. So that's one inverter. The other inverter's over there, and the NPPT charger is in the middle. It's got a lot of chokes, a lot of inductors. So the sine wave, it's supposed to be pure sine wave. The sine wave, I'm sure, has some harmonic distortion. I've seen one guy put it on an oscilloscope, and it wasn't perfect, but it should work. And for $1,600, it's a hell of a price point. So I'm gonna get two of these for a 12 kilowatt total. I want to be able to run at least one air conditioner off of it, and my electric range. Now it's just a stove top. Nobody ever burns more than one or two stove tops at a time, which are like 1,500 watt elements, I think. So some of the reasons why I bought this one, and there are other ones out there that I'm sure that do the same, is the price point, $1,600 or whatever it was, and is the hybrid feature, because I've always been concerned that if I try to hook up the house the way I want, which is almost everything, if it's too much for the inverter to handle, then it's going to shut down. Or when the batteries die, because maybe I don't have enough batteries, maybe I don't have enough solar, well, then the whole house shuts down, and I'm at work, and someone's got to figure out how to deal with it. This one has a hybrid pass-through function. So if at any point this gets overwhelmed, or the batteries get too low, or whatever, it'll just automatically bypass the input to the output up to 60 amps. 60, maybe 40. I think it's 40 amps. I believe it's 40 amps. Up to 40 amps, it'll bypass input to output. So if my PV array goes down or the load gets too heavy, the wife decides to use more than a couple of the stovetops at a time, it'll pass through and we're good. If it overloads it, then it'll just trip a breaker. So no big deal. It won't fault anything out if it puts too much current to these terminals. So I like this idea because I don't have a huge battery bank. It's only 19 kilowatt hours. So I like that idea, that the fact that it will bypass if the load gets too big, or if the air conditioner kicks in and that surge is too much for this thing, then it'll bypass and let the grid handle that surge and then go back to inverting and save me energy. So I only have to pay for the grid for that 1.5 seconds that it needs to surge to start one of the air conditioners. It's got, like I said, dual 80 amp input. I've got a 7.2 kilowatt Helena made in USA 18 panels coming. So I'll hook that up to here. The biggest drawback is the input voltage for the MPP is really low. It's 150 volt max, 145 volt max. And I think you have to keep it under 120 volts to actually utilize the MPP topography or the ability to charge efficiently. So when you have 40 volt panels, it really means you can only put 2 in series. So with 18 panels, I'm going to have 10 strings in a combiner, a midnight solar combiner out by the panels. But that's going to mean I'm going to have 80 amps coming in here. I'm probably like a number 2. So that's the biggest downfall is the MPP voltage is really low. But wire's not cheap, and that's going to affect some people. It's not going to affect me too much. I know people are getting wire pretty cheap. But the biggest concern that I have mostly is the batteries. Is that, like I said, it's only a 19 kilowatt hour, 48 volt lithium ion battery pack. So I've got a BK, 2 BK BMSs coming. So I'll be able to put one on each 3 section, and then I'm going to stack them on top of each other. I have a metal enclosure for battery backup that these are going to go in, and I'm probably going to cut the shelf right here and put that here just for fire safety and whatnot. And then the way I'm going to hook this up is I have a 200 amp panel with a transfer switch interlock. So right now that's a 60 amp breaker for the generator. So that is going to get interrupted down here somewhere. And I'm going to use this guy right here. So here's another 60 amp transfer switch. Right? You can't have them both on at the same time. So that's going to go on the wall down here. And that's going to be able to dictate whether I use the generator to feed this panel or solar. But the generator can handle all this for the most part, but the one inverter is not going to be able to. So what I'm going to do is I'm going to take the ovens off, and I'm going to take one of the air conditioners off, because I have a stove top, electric stove top, and then I have 2 double ovens separate. So I'm going to take the ovens off, I'm going to take one of the AC units off, and I'm going to put that in a second panel. So I thought about this, and I think this is the best way to do it, is I take this 200 amp panel that's currently fed by grid or auxiliary power, generator, solar, And I'm going to take these couple of big breakers out, and I'm going to put them in a second panel that only has grid power. But now if I have a second panel and this panel go into 1 meter base, 200 amp meter base, technically that's wrong. You can't, even if it's, I'm going to be using less electricity, I have the ability to run 200 plus a little 100 amp panel. I have the ability to run 300 amps off that meter base, which is too much. So the code doesn't like that, so that would need a 320 amp meter base, which is $500, plus 350 or 400 KC Mill service leads, which I don't want to do any of that. I don't want to deal with any of that. So what I thought of instead is the second panel having a pass-through lug. Now, this is a NEMA 3R rating because they're normally located outside for, like, you know, air conditioners and whatnot, and then a pass-through. So basically this is a 200 amp lug, 200 amp main breaker. So my meter base is going to come in from meter base to here. From here, it's got output lugs, 4-aught output lugs. That is then going to feed that 200 amp panel. So this way, it's still, both panels will be protected by this 200 amp breaker, and that panel will have its own 200 amp breaker, but I won't need to upgrade any of the service. And then in here, I'll be able to put my oven, the second air conditioner, and then also the inverter bypass, because that will bypass, right? So I have probably a 50 amp breaker in here for a bypass. So this will always have the ability to pull from the grid. And then everything else that I leave in this panel, which is going to be most of it, will all be pulling from solar only. Unless the solar breaks, I need a generator, and at the same time there's no grid, which ain't going to happen. Might as well just sell a generator. But I like this idea the best. And this was relatively cheap. I think this was like $170 or something. So this keeps the code rulebook happy. I don't have to upgrade the service. I don't have to do any of that. So that's the plan. So coming soon, there's going to be some panel videos and a ground mount. I'm not 100% sold yet on which ground mount I'm going to do, but I'm really leaning towards a brand. A lot of people say Iron Ridge, and then don't use galvanized, because galvanized pipe is apparently extremely expensive, which I had no idea. It's $700 per 20 foot, and I would need 8 of those. So I'm looking at another brand that does 100% galvanized I-beams, and they're made in Michigan. I live in Michigan, so that works for me. I can just go and pick it up, and that's probably going to be somewhere between $2,000 and $3,000 for me to go pick that up for a ground mount. Still think I'm going to get 2 of these though, just to make sure that we have the least amount of bypass, and that I'll also have more input capability for bypass. Then maybe if I wanted to, I can put all of those panels back on. And then still, the only thing that would be in here then would be the bypass power to feed that, or to feed that. So if I can get both air conditioners and everything on there, I'll save money every chance I get until my batteries die. Or if the solar's not enough, it'll bypass and go back to the grid, but it'll save the electric bill as often as possible while I have enough battery capacity and solar capacity. So I figured that was the best of both worlds. And then as I go, I can increase the battery pack or go from there. But yeah, this is what I'm thinking. This is what we're doing. Stuff's been bought, so there's no stopping it now. It's gotta happen. And the only other goofy thing was whether or not I wanted to use this second panel here as a sub panel for the generator, which I'm not sold on yet. I bought it a while ago because I didn't think I was going to be buying solar panels, which was basically so as the generator comes in, before it gets decided on which way it wants to go, I can do this, right? So it comes in here, and then I'll have a couple outlets. And then from here, it'll go to the transfer panel between solar and generator. And then up here between solar and grid, or generator grid, aux and grid. The thing is, I was thinking as if, well, what if the grid's down, right? The grid's down and I've ran out of power. Well, if I started the generator, I could then plug in that, maybe just have 2 plugs on the wall, one from grid, one from generator. And I could then use the generator to charge my batteries. And then also have it, I probably wouldn't use it for a bypass, but I would use it for using the house while charging the batteries, maybe because I don't have a grid ability to charge the batteries, which that will also charge off the grid if you set it up right, but I'll never have it set up for grid charge. It would be solar charge or generator charge, but I'm only going to do the generator charge if all else fails. So basically that's where we're at. Here's all the cables I got with that massive server rack UPS battery backup. Then I'm going to put on all these guys. This is actually, it's been sitting here for a while and it's never really been used. It had a couple of test run with these little APC 2000 VA dudes, but they only put out 120 volts. They don't do split phase. I've got a couple of them. There's another one on the floor there, but in the end, it's just really not user-friendly if I'm not home. So I'm going to make everything user-friendly and interlocked. So that's it. We'll go from there.